Used for windows, doors, and partitions, patterned glass panels add beauty and light to a room, but their purpose is more than decorative. The designs in the glass also obscure the view, making patterned glass an effective privacy screen. They let light in and keep prying eyes out. With patterned glass, windows become something to look at rather than through. There are a variety of designs and textures to choose from, offering different degrees of privacy. At the heart of the process are engraved metal rollers that transfer designs onto glass. Before production can even begin, this roller rotates through a chamber where grit blasts off grease and dirt. If the designs on the roller are damaged, they shave off the outer skin, exposing a smooth surface for re-engraving. But that isn't always necessary. Small problems can be fixed, so they circle those for repair. Some need no refurbishment whatsoever, so they move on to the next step. A worker brushes a polishing compound onto the printing roller. A buffing wheel rubs the compound into the roller's chromed surface, taking it from dull to a high shine. Meanwhile, in another part of the factory, craftsmen repair trouble spots on other rollers. The work has to blend in perfectly. The craftsmen do their jobs with the finesse that comes from natural skill and years of practice. One false move and the entire pattern could be ruined. But the touch-ups are perfect, and these rollers are now ready for the production line. The raw ingredients for the glass panels are stored in huge silos. These ingredients all come from the earth: sand, limestone, dolomite, soda ash, and salt cake. Here's a sampling in a jar. Conveyor belts feed a mixed batch of ingredients to a roaring furnace. They add waste glass and recycle it into the process to reduce the effect on the environment. Fired at 1600 degrees Celsius, the ingredients melt quickly. Now a molten mass, it circulates in a looped pathway. An inspector checks the melting status of the glass ingredients, as well as the flow of gas fuel to fire the furnace. This furnace is burning 24 hours a day, 7 days a week, and is monitored constantly. The hot liquid glass now flows between two rollers, one of them engraved. The rollers imprint designs onto the glass and squeeze it to its final thickness. The glass rapidly solidifies, fixing the pattern in the ribbon of glass. Then it travels through a 60-meter-long temperature control zone. The glass ribbon is exposed to flames to relieve stresses caused by the manufacturing process. This is called annealing. The glass slowly cools as it leaves the zone. This seals in strength and durability, so it can now be cut cleanly without fracturing. This cutter scores the glass lengthwise, but doesn't cut it all the way through. The scored line maps out the desired width of the glass. Another cutter moves to and fro to create horizontal score lines. These lines establish the length of the patterned glass panels. Then a roller pops up and breaks the glass along the horizontal score lines. The sides of the glass now collide with little wheels known as bonkers, which snap the glass along the lateral score lines. The waste glass falls down a chute to rollers that bust it to bits. These bits are called cullet, and they'll be recycled into new glass. A worker now backlights glass panels and examines their finish for flaws. This solar glass panel has a matte finish. Compared to the small sample of standard clear glass, it's less reflective, allowing more of the sun's energy to be captured. Minerals high in iron produce greenish glass that's light absorbent. For solar glass, they go easy on the iron to produce white glass that transmits light. A carrier with suction cups stacks the glass for shipping. Now all that's left is the window shopping.